Hello students, in this particular video lecture we will be going to study about the asset properties that each transaction needs to follow. Before moving to the asset properties, we should know what is a system log. Every system maintains a log to keep a track of all the transaction operations, so that if transaction fails due to any reason, we can use all the recorded operations on the system log to recover from that failure. Right, we can roll back our transaction using that all the operations that are recorded on the system log. Every transaction is identified by a unique transaction ID that is automatically generated by the system. So how the log is maintained? See this, we have start transaction T, which means that the transaction T has been started by the system. Start transaction T. This is the way to maintain the log. Next is write item TX old value new value. It means the transaction T is performing a write operation on the data item X, and it is updating the value of X from old value to new value. Then read item TX means transaction T is performing a read operation on the data item X. Next is commit T. It indicates that the transaction T has completed successfully. Abort T means the transaction T has been aborted. Now what is commit point? A transaction T reaches its commit point when all the operations that access the database have been executed successfully. So these are the asset properties of transaction. A stands for atomicity, C for consistency, I for isolation, D for durability. These are the mandatory properties. If the transaction does not follow even one of the property, then it is not a valid transaction. So let's start with all the definitions of these A, C, I, D. Atomicity means, we have studied this term earlier also. Atomicity means either all operations of the transaction are reflected properly in the database or none are. Let's take an example. Suppose this is a schedule. T1 is the transaction and it is transferring rupees 50 from A to B. Right, A is the account balance, B is the account balance of another person. Suppose it's have read the initial value of data item A, which was 1000 rupees. It has debited rupees 50. Now it has written the updated value of data item A to the database, that is 950. Then read B will read the initial account balance of B, that is 2000. It will add. Suppose before performing this particular operation write B, before performing this particular operation write B on the database, before the value of B is updated, suppose the transaction fails. Now what is the new values? For T1 it is 950, but for B it is still 2000. Right, it means rupees 50 is destroyed due to the failure. It means what a valid transaction should do is that it should roll back the value of A as well, so that the final sum of the values, the final value should be in the initial state. This is what atomicity is. And the transaction management component is responsible for handling the atomicity. Next is consistency. Execution of a transaction in isolation must preserve the consistency of the database. It means that the application programmer who is coding the transaction, he is responsible to make sure that the values of the data items are in the consistent state after the execution of the transaction. It means, let's take the example, the last example that we have just discussed, that the sum of A plus B should be unchanged. It means if I have transferred rupees 50 from account A to account B, the final sum should be the same. Money cannot be lost there. So it means the value should be in the consistent state. Right, and application programmer is responsible for ensuring the consistency. Next is the isolation. Isolation means that even if we are executing the multiple transactions concurrently or simultaneously, for every pair of transaction Ti and Tj, these transactions who are executing concurrently, they should be unaware of each other, right? It means they should not be interfering with each other. Let's take an example. Suppose we have two transactions. One transaction is transferring some amount from A to B and another transaction meanwhile reads the value. Then definitely it will read the inconsistent value of A and B. So it means even if they are executing simultaneously, they should not interfere with each other. The execution should be in such a manner that both the transactions should have a feel that they are the only one to execute in the system. They should have a feel that they are executing in an isolated manner, so that they should not interfere with each other and the final value should be in consistent state. Next is the durability. Durability means that after the transaction completes successfully, the changes it has made to the database should persist even if the system fails. It should not be like this, that once the changes are made to the database and then the system fails, the changes that are made to the database don't persist. They should persist even if the system fails once the changes are written to the database. And it is the responsibility of the recovery management component to ensure that there is durability. Durability means it should guarantee that all the updates that the transaction has carried out on the database that are written to the disk, they should be there on the database. It should not get modified even if the system is failed after the transaction has written the updates to the database. Okay, thank you class. In the next lecture we will be studying about the way what is a schedule and the various types of schedule, what is a recoverable schedule and what is a cascadeless schedule. Thank you.